Right. Good evening, everybody. In the last class, I have stopped with the topic. We have stopped with the definition dam. Actually, in last class, before. Before the previous class. Last class. In that, I have completed thermal power stations. Coming to the last class, I started hydroelectric power stations. I told what is the importance of hydroelectric power stations. And in last class, we have dealt with the various definitions of hydroelectric power plant. Okay, now let us come to know some more definitions. Let us deal with some more definitions of hydroelectric power plant, and we will see some dam photos, pictures. Okay, differences between different types of dams, and even internal parts. Pictures of each, pictures of some internal parts also. Let us see. Okay, right now I will start with today's presentation. Okay. Right, I think almost I ended the last class. Almost I ended the last class with trash rack. With the definition of trash rack, I think I ended around trash rack or dam. I think that was the last definition which I defined. I told that trash rack are the parts, trash, uh, these are provided in before, these are provided to clean the water before reaching to the dam, so that the turbine or penstock might not get affected because of debris or any sand particles or mud, or any larger size sand particles or mud particles, or whatever may be the obstruction. This trash rack helps in preventing, prevent in, in saving the turbine and penstock. Okay, right. Next is coming to penstock. I already have told about penstock. It is a pipe between the surge tank and prime mover. Okay, surge tank surge tank is placed like, and just once again I'll show. Surge tank is placed immediately after the dam to adjust the pressure levels in the penstock. Whatever, to adjust the pressure level, to adjust the pressure, to maintain the same amount of pressure in the penstock, you use a surge tank. Okay, so penstock connects from surge tank to turbine. Right, coming to tunnels and concrete pipes. What are tunnels and concrete pipes means? Tunnels are used as shortcut through mountain to carry water. Usually tunnels will be constructed, there will be like tunnels where trains and even by road also will be laid. It will be just like tunnel. It will pass between the mountain. Okay, tunnels are used as shortcut through mountains to carry water. Okay, through mountains, if we want to carry the water, then we create tunnels. The tunnels are usually lined to prevent leakage and friction losses. The tunnels are usually lined to prevent leakage and reduce frictional losses. Okay, these tunnels are usually lined to prevent leakage. Okay, these tunnels prevent leakages and they reduce even frictional losses also. Okay, that is only the inside layer of the tunnels will be lined properly. Right, next coming to the one more picture which is showing our hydroelectric power station. Okay, this at the left corner. Okay, and the left side of the slide, just take it is intake of water. Okay, and that water is entering into the tunnel. Almost this tunnel is, tunnels are usually used to carry water through mountains. I think here also water is being passed through mountain. Okay, right. From tunnel again it is passing to the turbine, and the remaining water, and after that water is being sent to tail race. Okay, we have a solid rock means it is like a mountain. In mountain only you are constructing the tunnel. Even you are having transformers at the right side of the slide. At the right end, you are having transformer, generator with turbine below. It is almost to the end, and thereafter you are having power lines. Okay. These crane regulates intake gates. Okay, whatever the gates are there, that will be regulated by the crane. Suppose if the water intake is more, okay, I mean the level of the dam will be reached, then definitely this cranes will open the gates of the, sorry, this crane will open the shutters of the gate, so that water will be bypassed easily. Okay, this is one picture, and this is also another picture which is showing, I think this is what your penstock they are showing. Okay, just a minute, I'll minimize the screen so that we will understand. Right. This is like this is a penstock only, where they are showing from inside, the inside of the pens, the picture. I mean, the picture from the inside of the penstock is taken here. Okay, now coming to surge tank, I will explain once again about surge tank. Okay, surge tank controls the pressure variations resulting from the rapid changes in water flow in penstock, thereby prevents water hammer effects. Water hammering is what is with, I mean, water comes with the pressure. If suppose the direction of the direction in which the water is coming, definitely water will come in. So of course, whatever the direction the water is entering, it will come and enter with a pressure. If suppose you are changing the direction of water, like you are taking water like this and you are trying to move it straightly, so definitely, I mean, water will try to will right, suppose this is a curve like structure, so water will try to hit, right, hit at the joint where you are bending or where you are twisting, there water will get hitted. So that is almost, that is called as hammering effect of water. Okay, that is the reason your penstock should be constructed very, I mean, your penstock should be your surge tank and your penstock should be constructed very strongly. Surge tank controls the pressure variations resulting from the rapid changes in water flow in penstock. Okay, so it will maintain the pressure level of the water in the penstock, thereby prevents water hammer effects. Okay, it is similar to a flywheel fitted to an IC engine. Next is anchor block. The anchor blocks are used to support and to give mechanical strength to penstocks. Okay, these anchor blocks are used to support and to give mechanical strength to the penstocks. Right. I mean, whatever the penstocks are there, in order to provide, I mean, it is just like a pipe. Okay, I mean, for that pipe to be strong or to be stiff, to be in a stiff manner, then you need to provide anchor blocks to the penstocks. Okay, what are turbines? Let us see. Okay, this is the photo of turbines, which are converting your which are converting your kinetic energy into mechanical energy. Right, coming to another picture also, which is also showing your hydroelectric power station. Right, here, here also, I mean, I think the photo of turbines, or I think this is the photo of alternator, stator and rotor. Okay, right, coming to the next slide. Okay, this is the stator of the alternator, I mean, the construction of the alternators photo. Right. What are the hydroelectric power plants which are there in Andhra Pradesh? Also, they have given Andhra Pradesh and Telangana. This is United AP's picture. So there is Nizam Sagar, there is Singhpur, there is Nagarjun Sagar, there is Sri Sairam left canal, and right bank canal and left bank canal. Next is. So these are all the hydroelectric power stations which are there in our Andhra Pradesh and Telangana. Right, lower head plant. Okay, head means, just simply I will tell, head means height of the water. Okay, so what I mean it measures the height of the water. See what is lower head power plant, just we will see. Okay, if the clouds are very nearer to the reservoir, see the height of the clouds is, it is very nearer to the reservoir. Whatever the water which is falling from the clouds, or whatever the water which is coming from the rain water is at a very lower height from the surface of the reservoir. So this is called as lower head power plant. It, I mean, which power plant should be built, that all will be considered based on that, based on the geographical area, like what is the height of the reservoir, and what is the height of the sky. I mean, is it on a mountain like that? What all are there? Everything we will observe, and they will try to construct. See, lower head power plant means the same hydroelectric power station, but the height of the rainwater which is falling is low. Okay, I mean the distance between the cloud and the reservoir surface is less. So it is called as lower head power plant. And here the distance between the water, the rainwater and the surface of the reservoir is more than lower head power plant. Okay, means it is a bit. There is a gap between. There is a there is more area between the clouds and the surface of the reservoir, then it is called as medium head power plant. Okay, coming to the higher head power plant, now the clouds are very high from the surface of the reservoir. Okay, so this is called as a high head power plant. Again, the same operation occurs. Again, there are the same parts, the same power plant. I mean, from reservoir, I mean, the water enters into the forebay. With the help of forebay, it enters into the dam. As dam increases the height of the power plant. Okay, forebay is just like an entrance. Forebay will adjust uh, the variation based on the variations of power demand. Forebay will help in adjusting the water from reservoir to dam and dam to reservoir. Okay, and next you are having a surge tank, and after surge tank, I mean surge tank adjusts the pressure. I mean it settles the pressure variations of the water which is passing through the penstock. Okay, penstock will pass the water from surge tank to powerhouse. Okay, in powerhouse, I mean this kinetic energy is getting converted into mechanical energy with the help of turbine, and this mechanical energy will get converted into electrical energy with the help of alternator. So they are showing with a glowing bulb, means electricity is getting generated. Now let us understand what are the advantages of hydroelectric power station. I mean already we have studied about the thermal, I mean first we have studied about renewable power plants like solar power plant, wind power plant, thermal, this geothermal power plant, okay, biomass power plant. This all we have studied, and from two or more classes, just we are also studying about, or we are also uh, we are trying to learn about the thermal power plant. I mean like non-renewable power plants. We have started from past 2 or 3 classes only. Okay, in that we have covered, or we have studied about thermal power plant. In thermal power plant, I mean, what are the advantages, disadvantages? We have known. Similarly, now we will see the advantages and disadvantages of hydroelectric power station also, and we will try to compare this advantages and disadvantages with the thermal power plant, so that we will have a better idea, or we will have a good clarity on non-renewable type of power plants. Right, coming to the first advantage, maintenance cost of the hydroelectric power station is less. What is maintenance cost? Means there are again two types of cost. One is fixed cost, okay, and second is running cost or maintenance cost. Okay, fixed cost will be high for this type of power plant, but running cost will be very less. Why? Because we are trying to store water which is naturally, which we are obtaining naturally from rainfall. or I mean from water walls, wherever I mean you are naturally getting water, you are not supplying water, or you are not trying to dig, or you are not trying to take out some water, you are not trying to transport, nothing you are doing. You are constructing a reservoir, you are trying to store the water which is freely available. So we can simply say that maintenance cost is less or nil. Okay, this is the first point. Next is advantages of hydroelectric power station. It is like a multi-purpose power plant. I mean, this usually hydroelectric power stations will be used as peak load power plants. Okay. Next is why it is called as multi-purpose means first reason for constructing a dam or a hydroelectric power station is to store water. Okay, is to supply the water whenever we are in need, like during all the seasons other than rainy season. I mean, other than rainy season, whatever may be the season, you need to have water. Okay, in order to have water throughout the year or throughout all the seasons of the year, then you are trying to construct a dam. Okay, so damming serving the purpose of a purpose of storing water. Next purpose again, the dam whatever it is storing is, it is also helping in generating electricity. So we can call it as it is multi-purpose. I mean, its use is multi-purpose. Next is third point is cost per unit is less. What I mean, as you are not purchasing anything, like you are not purchasing water, or whatever the as you are not having any initial buying cost, I mean, like fuel cost. I can tell you, as you are not having any fuel cost, whatever the energy you are generating, the cost which is, I mean, I mean, for 1 unit generation, whatever the cost which you are spending, or whatever the cost which you are uh, which we are charging, it will be less. Coming to the second one, it is high efficiency. See, simply I can tell that in thermal power station we are having all heating components, we are having boiler, superheater, economizer, air preheater. Okay, I mean, I think the boiler losses are only about 12%. Not only that, again we are having a major amount of loss in condenser. Why? Because I mean the complete heat is is turning. We are trying to cool the heat of exhausted steam. Okay, we are trying to bring the exhausted steam back to liquid water. So we are losing a lot of thermal energy, or we are wasting a lot of thermal energy, I can tell. So definitely that was the reason that I mean thermal power plants were very less efficient, right? Coming to this hydroelectric power station, you are not having any wastage like heating, okay, leakages, okay, like a boiler tank leakages or boiler furnace leakages, what will be ash disposal, whatever it is there. I mean, many types of complications are not there. Okay, and heat is not at all getting wasted. I mean, you are not using heat energy first, and whatever the energy which you are using, it is not getting wasted much. Why? Because for heating or for cooling, you are not, I mean, for heating or cooling, you are not doing here. So you are having, definitely I can tell that you are having high efficiency. Next is it is free from pollution. Right, hydroelectric power station will not constitute any will not constitute for environmental pollution. Why? Because whatever the fuel you are using is water. Okay, and whatever the machinery you are using, it is converting one form of energy to another form of energy. Okay, you are not heating, you are not doing any type of combustion, you are not using coal, or you are not, I mean, input is not any components of fuel, or and you are not using any petroleum products or fuel. So definitely you won't have any emissions into the atmosphere, or I mean any type of emissions will not be released into the atmosphere. So you can definitely tell, or I mean you can easily agree with the point that it is free from pollution. Right, it needs only a small staff to operate and maintain them. Yeah, obviously, this also I think we can guess. Why? Because thermal power plant, I think there are many components. I mean, like a boiler. I mean, what are the additional components which are attached to boiler? I mean, to increase efficiency of boiler, we are having air preheater, we are having economizer. Okay, and after that we are having condenser. Not only this, I mean, I mean, coal passing this you need to pass coal from coal storage plant to this boiler. Okay, and next, not only this, we are having I mean problem of ash disposal. Okay, next, whatever pulverization, this the like this, I mean additional works. Okay, like small, I mean pulverization of coal, storage of coal, I mean everything, I mean complicated things will not happen in hydroelectric power station. That is the reason that it needs a small staff to operate and maintain them. See, whatever the water it is coming into reservoir. Directly you are supplying the reservoir water to dam. Whatever the trash racks, whatever there are there in the reservoir, nearer to the dam, whatever the trash racks you are placing, and I think you need to clean them. I mean, even maintenance is there, it is very less. Why? Because components are only less, and the components are not getting, I mean they are not releasing any type of heat energy. Okay, I mean you are not pulverizing, or you are not reducing the size of food. Directly water is coming, you are storing, you are sending it to dam. Okay, from dam through surge tank and pump stock, the water is reaching to the turbine. Okay, so even though whatever the work the air it should be done, the work which should be done will be very less. So we need to, I mean maintenance staff also will be, maintenance staff requirement also will be very less for hydroelectric power station, whereas this thermal power station will not operate like this. First thing is you need a skilled labor in thermal power station. Why? Because every component is important and everything is associated with heat. Okay, there might be a chance that boiler might explode. So definitely you need a skilled person to operate. Here, I mean, you don't need much more staff, and I think whatever the staff is there, I mean, with minimum skills, I think it will be sufficient. It can put in service immediately, right? I told that it is a peak load power plant. Put in service immediately means like coal will not come like this. Why? Because first thing, coal should be stored, it should be pulverized. Okay, and again the after pulverization, the this fine pieces of coal should be passed into the boiler. Okay, and initial temperature of the boiler, if I start thermal power plant, if I start running thermal power plant now itself. Okay, I mean the boiler furnace temperature only, I mean in order to increase the temperature of boiler furnace only, it takes a lot of time. Okay, so it cannot be put into service immediately, means it takes a lot of time. Okay, even for a change of load also, I mean suppose if the load demand is reduced or the load demand is increased also, it, thermal power plant, I mean controlling of thermal power plant according to the load also will be a bit difficult only. Okay, I mean that the I mean controlling is difficult, but I mean whenever you want, if suddenly if you want to put into service also, it will not happen. If suddenly it also can't be taken out of service. Why? Because I mean later consequences will be different if we do like that. So what we need to do is, whenever we are put this hydroelectric power station, problem is not like that. Okay, as it is related to the water which is already stored in the reservoir. So definitely you can put into service immediately. I mean, thermal power plant can be used as base load power plant, but thermal power plant can never be used as peak load power plant. If we want a hydroelectric power station based on the storage of water in the dam, it can be used as base load and peak load power plant. If suppose if the storage of water is less and the running season is, I think, is a bit dry season like that, then definitely we need to go for peak load only. I mean, we can't use it for base load thing. Right. Coming to the disadvantages of hydroelectric power station. Okay. I think we have, as we have two sides, as we need to know the two sides of the coin, right? We are having disadvantages also of power of hydroelectric power stations. Thermal power stations, I think advantages will be more only, but disadvantages will be a bit less only compared to this. Okay, I mean whatever the electricity you are generating, if you are comparing with initial cost, I mean whatever the electricity you are generating throughout the year by using a hydroelectric power station, what I am telling that its initial cost, initial means installation cost or fixed cost will be higher. Okay, I have told that running cost is not there, or almost it is nil. okay, or it is less. But here what happens is initial cost will be very high for a hydroelectric power station. Why? Because construction is of dam is not at all easy. I mean, we need to put a lot of effort and a huge number of skilled, unskilled labor, along with technical persons like engineers. Okay, engineers, even the people from government, all of them should work, and it is not at all an easy task. It takes many years for a dam or for a hydroelectric project to come into role. Okay, so uh, coming to the disadvantages of hydroelectric power station, initial cost is very high, and I mean, I think it runs for more time. But if suppose the if suppose I mean the river which is flowing through the dam, or the dam on I mean the river on which this dam is constructed, if suppose there is I mean huge floods have come into that area, or if the level of water which is to be stored in the dam has crossed its limit, then definitely there will be a chance of this dam to collapse. If that happens, definitely it will be a major or a huge loss for us. Why? Because we have put in a lot of initial cost for this. Okay, I think running cost is not there, but initial cost we have put in very high, and it will take some 10 years it takes to come into operation. I mean, for the construction to finish and to come into operation, it takes a huge time also. So definitely, the first disadvantage for a hydroelectric power station will be its initial cost only. Right. Coming to the second point, area required is more. Why area required is more? Because you need to have reservoir. Usually, the place where we can collect water easily, you need to require. Usually, hydroelectric power stations are constructed nearby to the rivers or in hilly areas only. We try to construct. So definitely, whatever the area you require will be more. Why? Because this reservoir should be constructed, dam should be constructed. I mean, it requires some acres of land. So it's like a huge investment only. Like, coming to the third point, power generation depends on season. Right. This is also one deciding factor. Why? Because we have put in a lot of effort. A lot of people have worked for many years. Okay, they have put in a lot of money. But what is happening? We are able to store water, but we are unable to generate electricity throughout the year. So that will be again one disadvantage for us. Okay, that disadvantage is power generation depends upon season. Okay, power generation, like this is not in the case of thermal power plant. In thermal power plant, whatever may be the season, almost 3 months of advanced stock will be there in your cold storage or in your coal bunk. 3 months of advanced cold storage will be there. Okay, so whatever may be the season, okay, however it may be, easily, as the coal is already stored. I mean, you take a daily 3000 to 4000 tons of coal will be passed from cold storage equipment, from cold storage area to this boiler. Okay, and based on the passage of coal, I mean, you get energy generated. But what I want to tell is, power generation in thermal power plant, it will never depend upon season. Okay, whereas in hydroelectric power station, definitely power generation will depend on season. In summer season, as we will be in short of water. Okay, so I mean, no, as there will be no rainfall, we will be in short of water also. So definitely we can't generate electricity. Means this plant cannot be used as base load power plant. Base load power plant means it should supply throughout the year. Like thermal and nuclear power plants will supply throughout the year. Why? Because we have sufficient number of nuclear reserves in the country. We have sufficient number of coal reserves also in our country. As we have sufficient number of fuel content in the country, definitely advanced storage of fuel will be done in the storage unit of the power plant, and based on the load requirements, the operation will be done and electricity will be generated. Okay, so thermal and nuclear power plants can be used as base load power plants, whereas hydroelectric power station can only be used as peak load power plant only. Due to remote area, transmission losses are more, right? As it is, I mean, usually our hydroelectric power stations like Nagarjun Sagar, Sri Sailam, okay, these all are in remote areas. Okay, as the river should be flowing there, or you need to have huge supply of water. So definitely these hydroelectric power stations are constructed at remote places. So what happens is, as they are not constructed at the ends, or at the major points of the cities, so what happens is transmission losses will be more. Why? Because you need to transmit that power from one place to another place. Wherever you are generating this electricity, or wherever this hydroelectric power plant is there itself, the electricity, I mean, that much amount of electricity might not be useful there. I mean, I think people may be living or may not be living. Okay, if even people are residing also, I think whatever the electricity consumption made by the people people living in the remote area might be very less than the electricity which is getting generated. So definitely you need to transmit that power from that place. So transmission losses will be very high in a hydroelectric power plant. Right. Next is coming to this. Almost, I think I have taught. There are some new points which we need to understand, or which we need to know. Okay, what are the new points which we need to cover? I will tell here. Okay, I mean, in this major topics or major definitions I have already explained. We will see some more pictures regarding to this components of regarding to the parts of hydroelectric power station. Okay, right. Next, on the completion of this topic, you will be able to know the catchment area, reservoir, dam, forebay, trash rack, penstock, surge tank, spillways, draft tube, tail race. Okay, right. I think I have covered reservoir, dam, forebay, trash rack, penstock, even surge tank also, spillways also. I think for us, new points or I mean, new new parts which we have not yet covered are catchment area, draft tube, and tail race. Okay, I will try to explain that first. Okay, and we will, and for the remaining things, whatever the diagrams or whatever the pictures they have shown in the PPT, we will, whatever the pictures I have put in this PPT, we will try to cover. Right, coming to catchment area. Right, coming to catchment area, there in the figure there they are showing. See, in between whatever they have constructed in between here. Okay, it is a dam. Okay, that that area whole, it is of water. What is catchment area? Means the area behind the dam which collects the rainwater, drain into a stream or river. Okay, the area which will collect the rainwater, rainwater. I mean, catchment area. How it will be means, how they will construct catchment area means, wherever the rain may fall in that areas, easily the water will reach to the catchment area, and this catchment area, and I mean, after that, or this catchment area will be behind to your dam, so that the water easily will enter from catchment area into the dam. Right, collects the rainwater, drain into a stream or river. Right. It is represented in square kilometers. Catchment area is represented in kilometers square. Right. Next is coming to the reservoir, the place at which the water is stored in a dam. Okay, the place at which water. See, catchment area is behind behind, I mean the last in the photo, whatever they are showing, the corner part of the water or the last water is called as catchment area. The area in which the water, the last area, where the arrow marks are being shown, that is catchment area. Before to that, I mean after that, okay, after that you are having reservoir, the place at which the water is stored in a dam. Okay, a reservoir just comes to the behind of dam. Catchment area comes to the back of reservoir. Okay, reservoirs are again of two types: natural reservoir at high altitude, artificial reservoir made by constructing a dam. Okay, natural reservoir means I already told that in mountain regions or at high altitudes on top of some hills, naturally you will have reservoirs where water gets collected easily, in catchment area, and it will move into the reservoir. Yeah, artificial reservoir, if we want, means we try to construct this artificial reservoir just before the dam. Right, already we know that what is dam. Okay. Mm, why I mean dam is used for storing the water. It is to provide required water head, even in order to increase the height of the water. Why? Because height of the water only matters. Okay, if the height, if you are trying to pass water from a heighted place, then definitely the potential energy of that water will turn into kinetic energy, and automatically the blades of the turbine will start rotating. Right, what are the views of dam? We will see. Okay, this is powerhouse on the left side, and right side you are having dam. Okay, powerhouse means it is downwards, dam means up. Right, why? Because while powerhouse will be at will be below, and while dam will be at up means whatever the dam you have there, water will be stored. Okay, water, as we all know that water flows from high pressure area to low pressure area. Obviously, for the water to flow from high pressure to low pressure and to create some force on the blades of the turbine, definitely we need to have dam at at a higher altitude, or dam should have have a large head or more head. Your dam should have. Below to your dam you need to have powerhouse. Okay, what is powerhouse means? I mean the place where you place turbine and alternator, and from there whatever the substation, whatever the transformer to which you give at the end of alternator, that place is, or that this whole unit is called as powerhouse. So powerhouse will be at bottom and dam will be at the top, in order to pass the water easily and convert potential energy to kinetic energy, which will finally get converted into electrical energy. Okay, these are the two figures which are dealing with the views of the dams. Right. These are also the pictures of dam only, figure 4 and figure 5. Figure 5 they are showing dam only, but along with the dam they are showing, I mean that photo they have taken from the nearer point. So we are able to see the spillways or the gates, and the gates are open and water is coming out. Right. Coming to Nagarjuna Sagar Dam, I already have told that it is a good site, or it is like a good tourist place also. Whenever rainy season comes, there are 26 gates. Okay, I mean the gates almost, I think the gates are open and the water is coming out of the gates. Okay, right. Next is forebay. Water carried by the power canals is distributed to various penstocks leading to the turbine through the forebays. Water carried by the power canals. Power canals means whatever the reservoir, whatever you are having, that is sent to the penstocks, which will go to the turbine through forebay. Means your forebay will be before to that of dam, or it will be just after the reservoir, before your penstock. Okay, water from the main reservoir before entering into the penstock, you will have a forebay. So that this forebay, I mean suppose if you want to shut down the turbine, or if the power demand is not there, or if the power demand is increased, then this forebay regulates water flow from reservoir to penstock and penstock to reservoir. It acts like a mediator, and it maintains the level of water without sudden surges. Okay, it serves as a regulating reservoir to store water temporarily. It is used when the distance between the reservoir and powerhouse is more. Right. Usually, where forebay is used is if the distance between reservoir and powerhouse is more. I mean, if there is a larger distance, then what happens is suddenly, if you want more amount of water, then it I mean, some time will get consumed. Or if you don't require water, if you want to stop the water, then also you won't have. I mean, suddenly you can't stop because already water will get passed through some area till the time you decide. So what they do is in between if you are as the distance between the reservoir and the turbine and powerhouse is more, then they will put a forebay arrangement so that this forebay helps as a regulating reservoir. If suppose you want some more amount of water, then this the and water which is stored in the forebay, immediately it will enter into the powerhouse. Or even if you want to stop the water there itself, I mean, if you want to stop the production of electricity, then I mean, water will be I mean, water will get stopped at the forebay itself, so that it will not create a time waste, or it will not create a burden on the penstocks or turbine. If suddenly if there are any changes in the load demand, so definitely this forebay will help if there is a distance between reservoir and if there is a larger distance between reservoir and powerhouse. Right. Next are, I think they have given a clear view about trash racks. See, they are in black color, and they are placed vertically. Right, they are placed vertically. They are used to prevent the entry of debris into the turbine. So they are preventing the entry of debris, means only water should enter from reservoir into the turbine. Okay, from reservoir, whatever the water is coming, the water only water should the debris or the sand or mud particles, whatever the grass particles or small plants, whatever the wastes of animal, whatever they are there, that all will be removed by these trash rocks. This built up from long flat bars set vertically. Okay, they are just like they are vertical in shape. Okay, space between bars 2.5 centimeters to 4 centimeters or 15 centimeters to 20 centimeters. Whatever the vertical trash rack bars you are placing, the distance between the bars also they have given as 2.5 to 4 centimeters or 15 to 20 centimeters. Right. In today's class, I have dealt with almost, I think we have covered almost all the definitions which are related to hydroelectric power station. I think draft tube and tail race are left over. In the next class, I'll deal with the definitions, and almost in the next class, we will try to complete hydroelectric power station. Okay, thank you for having patience. Okay, right. Let us end the class for today.